This is the 2011 HSC question 8, 8A part 2. You would use, of course, cosine rule to find, to come up with this equation for x. And then I would use the quadratic formula to do the second part of the question. So the second part of the question 8A part 2, definitely I would use the quadratic formula to do that. And I'll just show you. So just got, here it is, x is 20 plus or minus the square root of b squared, which is 400, minus 4 times 1 times negative 84 over 2 times 1. So it's 20 plus or minus the square root of, now 84 times 4 is 336, I think that's 736 over 2. Get 20 plus square root of 736 on 2, or 20 minus square root of 736 on 2. One of these is going to be a negative answer, so you would ignore that. Not sure what they mean by the acute angle in regard to these. I just think they mean the positive answer. So whatever that's equal to should be your answer. In regards to this, harder geometry, look, you should just know everything for geometry. Part of it might be hard, part of it might be easy. So I can't even remember like the one in task 1. But look, there's only going to be not many questions on geometry. So, you know, I wouldn't be spending so much time on it, okay? But you should be comfortable with all types of questions that you might get. Now, in relation to 2015 paper 12A, I'm going to have a look at that now. Joanne, if this is the question you're talking about, question 12A in the 2015 paper, I'm assuming it's our 12A. So for what values of x is f dashed x greater than 0? Well, this is the sketch of the function y equals function of x. So f dashed x is the gradient. So they're asking where is the gradient positive. Now the gradient's definitely positive for values of x. I'm getting, this is positive gradient here. And at a, the gradient's 0. So I'm getting that the gradient's positive. So f dashed x is greater than 0. For x less than or equal to for x less than negative 4. I'm also getting that the gradient is positive between the values of negative 2 and positive 3. So f dashed x, is positive also for the values of, actually it's not x less than negative 4, it's x less than negative 2. So negative, I'm wrong. I'm totally wrong. 1 minute. Okay, I'll start again. Positive gradient is from x is less than negative 2. Okay, so positive gradient for x less than negative 2, but not for x equals negative 2, and also positive gradient all the way here from x is from negative 2 up to 3. So I'll just write that down for you and you can have a look. So the gradient f dashed x is greater than 0 for x less than negative 2 and for values of x between negative 2 and 3. So as I've written here, x less than negative 2 and between values of x from negative 2 to 3. And where is the second derivative less than 0? Second derivative is about concavity. So second derivative means concave down. Now clear the curve is concave down for x less than or equal to negative 2. So second derivative is less than 0 for x less than, less than negative 2, not or equal to. Second derivative equals 0 at x is negative 2 because you've actually got an inflection. So second derivative less than 0 for x less than negative 2. Anywhere else that's concave down would be from, see this is concave up and now we're concave down. Also for x greater than 1. So the second derivative is less than 0 for values of x less than negative 2 and for values of x greater than negative 1, greater than positive 1, sorry. I'll just show you that there. So second derivative less than 0 for x less than negative 2 and for x greater than 1. I'll just have a look at the answers you saw. This question here, the maximum value of the graph, y equals negative sine x plus 2, you sketch it. And that's how you find the maximum value of the graph. So I'll just do that now. Y equals negative sine x plus 2. So sine x looks like this. Negative sine x looks like that. And negative sine x plus 2 would be to shift it all up 2 units. So instead of that being at 0, 1, and negative 1, bringing that up 2, we start at 2. 2, this will be 1, this point, sorry, bringing it up 2, 1 sec. So instead of 0, that's now 2. Instead of negative 1, that's now 1. Instead of 0, that's now 2. It goes like this. Okay, so the highest point will now be 3 instead of 1. Okay, so therefore your question was the maximum value will be 3. Okay, so maximum value is 3. Look, the maximum here at the moment is 1, and if you move everything up 2, I can even cross these off and go, well, that's 3 now, that's 2 now, and that's positive 1, and get rid of that axis. The maximum value is now 3.